Welcome to a new test and teardown video. This is the last of my BBC Goerz Unigor A41. Yeah, this is the last one I got. I think this one is super duper fully featured, as many different features available as you got clicks on the pot meter in here in the switch, right? So this is the test of the battery. It is a little bit low, but yeah, it is within this field, and then you can put it in off. So that seems to be all right. We got 5 resistor ranges now. Isn't that something? We got quite a lot of voltage range, all the way from 6 millivolts. This I really gotta see if that is right. Microamps, I think this is more or less the same as in many of the other meters. And of course they're using 6 amp, 30 amp. You just use this one instead. Of course, this is a brilliant way to save switch positions because you don't have that many. And of course, you can switch between DC or AC of anything. And you can reverse the polarity of your voltage or current or whatever input. Of course, it needs to be like this for resistance to work. So far so good. The knob here feels really good on those models on the A40 and the A41, so they solved that from the previous versions. Let's start with the resistance measurements, because that is important to know how that is done on this model. The A41 is different from the A40. So if you got the A40, this is not the video to look at because it's going to confuse you, okay? So if you got the A41, you are on the right video, and now we'll show you how ohms is working. And see, ooh. And then you adjust here. And this is actually also explained on the manual. I don't know if this is pretty clear to you, but of course it says here, adjust with open terminals, right? So you have nothing connected, then you dial the pot meter, and then it goes to open like this, okay? So far so good. We got it adjusted correctly. Times 10. Okay, so that means if I want to have here, so this is 20 ohms. Okay, I'm gonna find something near that. And if we look more carefully, this is 20 ohms. Oh, why are you doing that? Oh, it's because the hook fell off. But I mean, this is definitely accurate. 20 ohms. I love it. It works. Of course, it is a little bit confusing to my brain. This is reversed in this model, but hey, this is how it is. But if you got 2 of them, the 40 and the 41s, oh man, you're gonna be confused. Let's try and use the next range. Okay, of course in the next range we need to fine tune again. So now it's times 100, so I need 200 ohms to get to that point, right? And again, 200 ohm we got, and yeah, it is spot on, as accurate as I can see. So this is the next one. It's time 1000. So, of course, every time you change range, you need to fine tune this. Maybe it's because my battery is a rechargeable. Oh, and this is still my 200 ohms. So now it's all the way down there, and even that is accurate. Normally down in this range, you would expect a little bit of funny stuff. Let's see what happens if I short. It even goes to 0. I mean, I can't help being a little bit impressed. Let's try and put in a 2K. I think the story repeats itself. 2K is of course 2K and super accurate. Okay, let's go to the 10K then. And that is accurate. Oh, we forgot to do this. Open this. Okay, so now it's spot on. Of course. The closer you go here, you're using less and less current, and then that means the battery voltage and stuff is not going to affect anything. Alright, I got it. There's a pretty good explanation for that. So this is my 2K, also spot on in the times 10K range here. Fantastic. And yeah, I can continue to do this. This is 20K, and it says, ooh, I think I can actually reveal. Okay, if I do like this, but if I am here in the middle, yeah, I would call it spot on, right? So yes, that is 20K. And this is 200K, and it says 2. Yeah, times 200K it is. Hey, how about we see? So that should be 2 mega ohms, right? Let's see if that works. It just keeps confusing me that it goes the other way. It's annoying. I have only 2 mega 2. So that is, let me see. You see, it is actually just a little bit over 20. So that is possible to see it is more than 2 mega ohm. So it covers really a very big range, this meter. So that is very useful back in the good old days. I'm just briefly going to play with the super small range and the top range just to see if it's spot on there, because it's all of them are just super good. So this is the 6 millivolt range. I am reading, it will be that one, right? 5.1 millivolt. And just to be sure what I'm doing, this is where I input something and this is where I check what I got. And it says 5.2 millivolts. Okay, let's have a look. 5.2. Oh, 5.3. It is climbing a little bit. I think my power supply is warming up. Oh, this is very revealing what is going on when you're in the super sensitive ranges. Okay, let's go in the easy range. 15 millivolts. So where are we now? That is the top. So let's crank it up a little bit. What have we got here? 7 point. Why can't I get something more accurate? This should be a little bit under 10. 9.8 is what I got. And see, this is exactly 9.8. So it's really important to verify exactly what you input. What you think you input is not good enough, right? We need to know. So this is 9.8. I told you. So this meter is just really crazy. Let's go to 3 volt. That should be easy. Okay, so 3 volt is, where are we? We are here. And let's crank up That was 100. That is 1. And then we go. Where are we? Oh, is that accurate? Yes, that is damn accurate. So that is 2. Ooh, it shows a little bit too much. Oh no. And that will be 3. And it shows a little bit too much as well. Yeah. Whatever. I think I'm done playing with this. It's absolutely perfectly fine, right? I think we should stop falling around and look inside. This is a little bit different, so I took off this back plate, and this is using a sub-C cell. Now, why are you doing that when nobody got those cells? Everybody got AA cells. That is lame. And the A41 uses an AA cell. Why change something that was absolutely perfect? And the cell was out here where it was perfectly visual and but anyway, there's a funny metal shield around the cell. Extra fuses, super happy. The fuse is okay. You can access the fuse without taking the cover off, and everything here is sealed, even with this one and with the little varnish in the hole here, so I know nobody was in here. So let's open. So now we are inside the A41. And now they're using an older type of PCB again. Single layer. No, it is double layer. Yes, it definitely is. You can see some tracks down there and stuff. Yeah. And then we got this foam is not turned into puke yet, so that is good. Got 3 decks on the switches. Still got, this is done more or less identical. And again, this oopsie doopsie. So the overload relay and all this overload switch is still exactly the same. And here is the connection to the shield inside the case, and here it is. What a nightmare to put all that stuff in here and tape this here and tape this there and bendy and do the thingy. Oh my goodness, that looks expensive, but that is definitely how it was done. And those thin I don't know what you call that. This is the 30 amp, so it goes up here and through the PCB via. Ooh, I got puked. What is that? What did I touch? Ooh, that was gross. Where is it? I touched something and now my finger is completely goopy sweaty. But I can't see what I touched because there is puke. And the 30 amp sense resistor is that big baby there. Oh man, that's a big one. And the next one is of course the 6 amp and so forth. See, they're much thinner and they cut it upside down, zigzag to give it more resistance, and then it goes low, and all that. That will be all the resistors for currents, fantastic, and all that. good things. There was one, oopsie doopsie, there was one more thing that I saw here. That one looks like a temperature compensation. This is an NCC. Look at that. So that is something, and there is a what is that? A sheet of brass. So there's shielding here in the front. Now there's a micro switch as well. So when you're dialing this one, somehow we're going to activate. Oh, here it is. The thingy here. When is that going to? Aha, it's going to activate in the off. Really? I think I hear it. Yes, it is. Okay. So that is the thing. This disconnects the meter, maybe. I don't know what that disconnects. Anyway, I saw one other little funny thing here. Now we are using 0.1% resistors. Look at that. That is some expensive goody stuff. Yes, definitely. I think all the green ones you see here, that will be 0.1%. Why not do it super duper if you can? How are you gonna access those trimmers, by the way? Maybe that one is possible, but that one you need to be a magician to access. Why isn't this just as easy as that one? And why not right next on the PCB exactly what this does, or even write it here? So some noob like me could just trim this thing, right? Not that it needs trimming at all. So what do you think that is? Over voltage spark over at exactly 1.2 millimeters to blow the fuse if somebody gives it more voltage. That is what it is, right? Let's try and compare. This is the A41, as you can see here. Let's try and compare this with the A40 side by side on the inside. Isn't that amazing? This is like day and night. Everything is completely different. I think that is just so much fun. Hey, let's make everything from a start once again. Okay, let's just reuse the big round plastic things. Let's reinvent the wheel on everything else. What else did they even? Okay, at least this is the same. Some of it is the same, right? But all that fantastic thingy they have done here. No, that is... I don't get it. When I design stuff, I definitely always go for as little change as absolutely possible, add some more fantastic features, as many as possible, and as cheap as absolutely possible. Don't screw around more than absolutely necessary. Yep. But they got different ideas. 4 sections, and I don't know what. And this one got much less features. Yeps. So I think this is what I had to say about this fantastic A41. It is definitely a lot different. See, there's no brass shielding down there as well. And also, if you look at the front page, or the front side here, of course, also got some screws so you can take off this. Maybe they got them in different languages or whatnot. And the last thing to do is to show you the rear side, so you know how to find it. I'm sorry this version here is in German, but I think you get the point.